Here we go. Alright, let's do tangent of pi over 3. If I multiply by 2, I'm going to get 2 pi over 6. Up here is 3 pi over 6 because that's pi over 2. Yes? 0 pi over 6. So, that's a 2. So 2 is closer to 3, so my angle is going to look like something like this. Now, I know that this distance is 2. How do I know that's 2? Because I look at the 0 and the 2 that I need, and this is a distance of 1, right? 1 plus 2 gives me 3. That's the complementary angles. Now, to draw my triangle, it's the bow tie, so I'm going to draw it to the x-axis. There is my right triangle. Hopefully, let me point out something from geometry. This little angle is the same angle as up here. Let me say that again. It's just such a small thing, but this angle, that's part of the triangle. That's called the arc angle, is the same thing as this angle down here. So in angles, we would never say that, oh, this is a bigger angle than the blue is bigger than green. We wouldn't say that. They're actually the same. Remember, angle measures just, it's a measuring of the distance. It's not like a length. That would be arc length. Do you see the difference? Okay. So hopefully you knew that theta prime is 2 pi over 6, or pi over 3. Raise your hand if you got that. Okay, now then I just need to figure out how much is that in degrees, and that might help you. Remember, this is pi equals 180, so 180 divided by 3. My theta prime is a 60-degree angle. Then if I use a 30, 60, 90, I have 1, 2, radical 3. So across the 60 is going to be a radical 3. That's my y variable. Across the right angles, r is going to be 2. And then the last one's going to be this is a 30 degrees. So across here, my x value is going to be 1. I'm going to check my positives and negatives. Going to the right, it's positive. Going up, positive. R value, always positive. Then tangent is y over x, so I can just do radical 3 over 1. My answer is radical 3. Raise your hand if you got radical 3. Now, I want to tell you something. It is possible, like I did right there, you can actually convert this into degrees. And you don't have to work with radians. Why is that the case? Because it doesn't matter if your angle is in degrees or radians, your answer is just 1/2 radical 3 over 2. Does that make sense? You don't have an angle measure when you're done. Okay, let me show you how fast this works with the unit circle. If I locate pi over 3, so 0 pi over 6, 1 pi over 6, I'm skipping the 45s, that's 2 pi over 6, right? Pi over 3, 60 degrees. You might be saying, Mr. Ng, I don't see radical 3. Well, remember, tangent is y over x. Okay, watch this. I'm going to cover up the 2's. Y over x. Radical 3 over 1. Your answer is radical 3. Now, this also tells us something we're going to learn in 2 weeks. This is the quotient identity. Sine divided by cosine is equal to tangent. You don't need to know that. What you do need to know is that you can find the y over the x to get tangent. At pi over 3 is radical 3. Okay? Let's try cosine of pi over 2. If you were drawing this out, pi over 2 is a quadrantal. Class, what's the order pair? So x, y, and your r value is 1. So cosine is which 2 letters? And what is your answer? 0 over 1, which is 0. Raise your hand if you got that one. That was last week's lesson, quadrantal angles. There is no triangle. And how does that work with the paper plate? I go up to here at the quadrantal, cosine, sine. So the answer is cosine at pi over 2 is 0. See it? And let's try cotangent of pi over 2. You can use the same picture. Cotangent is x over y. So 0 divided by 1, your answer is 0. Let's locate that on our trig paper plate. Pi over 2 is 90. X divided by y. 0 divided by 1, the answer is 0. So 3 examples of using radians to evaluate our special right triangles and quadrantal